Hello everyone, this is MsDeep Singh Shekhawat and today we are back with a new video in which we are discussing how you can design a system which can help in deduping and then finally storing the image. Basically, we don't want to store the duplicate images again. So let's take an example. Let's take like this discussion is specific to Uber Eats, but let's take a simple example that you got a message on WhatsApp of image, and then you forward that image to another person. Okay, that person forward that image to another person. So if you see, the same image is circulated in the network multiple times, and for the time being this image will be served at the servers of the messaging application, right? In case of WhatsApp, the WhatsApp deletes certain messages after a certain time, but there are messaging applications which stores the message at server end. So for the images or for the same videos, if we can somehow detect them before storing, that if it's actually a duplicate or not, if it's a new image or not, then what we can do, we can actually save our costs on the storage. So today we are discussing that same solution in case of Uber Eats. Uber Eats has the same specific use case that people upload the images of product catalog, that what they are selling and all, right? And these images can be same. Let's take an example of a bottle of Coca-Cola. Okay, let's take example of Parle-G biscuit. The product will look exactly the same no matter on which grocery store it is being sold. So but like the images of foods can vary, but the images of these kind of items will always be the same. So why do we want to store them again and again? There is no point, right? So to avoid that, we have to design a system such that we can actually avoid that, right? Before moving further, if you are new to the channel, if you haven't subscribed to the channel MsDeep Sim, consider subscribing. You will learn a lot of things around distributed system design and cloud. So let's get into our problem statement. What are our requirements? So requirements, as I said, right, we need a storage system in which we want to store different kind of images, and those images should be stored only once. So that is our basic requirement. Now moving further, identity duplicate image, and then we will only store them on. One additional thing which we want to do is, so again, see, the Uber Eats system or any in messaging applications, we don't care about the quality. Like the user will send the message, user will send the image whatever he wish to, whatever she wishes to. We can't actually interfere in that, right? But in case of a product catalog, let's say Amazon, right, where different products are sold, or let's say Flipkart, or let's say Uber Eats, or let's say Zomato, any kind of these systems, they have to display the perfect images so that the users gets the actual view how the product looks like. So to validate on that quality, the system should also ensure that the image is of proper quality, or if there are any videos, those videos are of proper quality, they are of proper specifications, specific format, specific size, and all those things. Okay, so our system should be able to handle that. And this is the basic scale numbers. They are kind of huge because we are operating at scale. Now let's look into our current system, how it does is, and definitely then we will move to the new system which will solve that problem. So right now, what you do is you directly process the image URL, you generate the URL of you have that image of URL of the processed image, and then finally you store that original image and processed image and maintain that catalog. Okay, so this is the actual process looks like. If you see in this architecture, if you see in this entire architecture, we are not validating if the image is already stored or not, right? We are not doing that. So if we talk about limitations, we are not using any of the images. And there is one more problem. If the image is updated, if the same image is updated, you have to generate a new URL for that image. Okay, so what you are doing here, you are maintaining two copies of an image, and the earlier copy of an image might not be at all relevant. So you are just dumping that image into your storage, but it might not be of any use in the case of future. So let's solve this, both the limitations. So this is our new system, how it looks like. If you go to the structure, how we divided system is you have three maps specifically. Okay, we will go to the system later, but if you look at the storage, how the information is stored is you are maintaining three maps. First map is URL map, then you have processed image map, and then finally you have original image map. The URL map will have key as image URL, the original image URL, and that image hash of it. Okay, now finally the processed image map will have image hash plus processing specification. So the image hash which is being stored here plus the processing specific, as in the what is the size, what is the aspect ratio, right? These kind of specifications. And finally its value is processed image. And then you have original image map which stores the image map and then the original image. Okay, it do not include the processing specification. So this is how like we have divided our like structure or logic into three maps. They basically maintains how your older image or original image looks like, plus how your processed image looks like with both those kind of specifications. So if you see here, you have image hash, the original image hash plus the processing specification, and for that you have this processed image. Okay, now if you look into the logic how it works is, so let's say you have got a new image URL. You have to you got, let's say the user uploaded a URL or a system uploaded the URL of an image. So we are this system, this image processing system will receive that URL and then begin its, so this is our image processing system. Okay, so you got that new URL. You will check first of all that if it's that if that URL is already present in URL map. Okay, this first map we will check, if this image is already present. Okay, let's first go via a scenario that it is not present. So if it's not present, then you will download the image. Okay, you will get the hash and update URL map and original image map. So right now you are updating two maps here. One is URL map and one is original image map, where you are first creating the hash. You created the hash, so you updated this. Okay, you image URL to the image hash, and finally with this image hash you are also storing the original image. So this is what you are doing if the image is already not stored. Okay, finally you will go to in processed image map if that image is not in processed image map or not. So in the first case it will be not. So in that case you will check if the image is downloaded image is downloaded or not. Okay, so if image is not downloaded, then you will read that image from original image map, then you will process the image and then update the processed image. Okay, in the first case it will not be present, right? So what you will do, you will read that image, from original image map. Here you will get that image, you will download the basic you will download the image, and then you will do the processing as in validating that image. Once that is done, then you will process the image is processed, and then finally you store that into processed image URL, and then you return the processed image URL. You store in the processed image map, and then you finally return the processed image URL. Now in case the image is already present, okay, the image is already present in URL map. So what you are doing, you will read the hash of the image, you will read the image of the hash here in this case, and then you will check if it's processed or not. There might be some scenarios where image was already there in the URL map, but it was not processed before. So you will again check here if it is processed or not. If it's processed already, then you will directly read the processed image, and then we will return the image URL. If it's not processed again, then you will again check the same flow which we discussed already. So this is how our structure looks like of our system, and how the logic works, so that you can basically avoid the duplication of the images. Okay, now if you talk about the data store specifically, this doc store is Uber proprietary data store, which is used by them essentially for their storage needs, and this is to store any metadata and the URL map. So in case of URL map, you are not storing the actual image, so the only metadata which you are storing or the URL map which you are maintaining will be stored here. They have their blob storage, Terra blob. Like I personally haven't used it or looked into it, but it's similar to Amazon S3, where you can store the object storage content like images, videos and all. So they are using this for image storage. So essentially, in case the processed image or the original image, you are storing with the help of your blob storage, which is called Terra blob. You don't have to definitely not know about TerraBlob. It's similar to Amazon S3 or any of the object storage you used on the any of the cloud provider. Now another thing is let's say you got that image hash, and with that with specific processing in specifications, we are all okay. Let's take a step back. Let's say that you got an image and that image is not of proper quality. Okay, that image is not of proper quality. Now what you are doing, you are processing that image, right? In this step you are processing this image. Now in processing of this image, it might be possible that image is not up to the proper qualities. So in that case, what you will do, you will store that error message. You will store that error message in your processed image map. For this image hash, for this processing in specification, this is the error message. Okay, I already processed this image, but this is not of proper quality. So how it will help is on subsequent calls with the same image URL and again the same specifications, you will directly return the error without processing it again. So this is how it helps on, basically you are avoiding the reprocessing of image again and again, right? When you are saying that you are avoiding the storage of the image again and again, you are also avoiding the processing this logic again and again. You can directly go via this pipeline. Okay, this is your ideal flow if the image was already processed in the first go. Okay, now the second thing was what we mentioned was that if the image is updated or the image is updated, you have to generate a new URL for that image and then it is stored again, right? But our use case was, our problem statement was that we don't want to do that. So what you will do in that case, so the first steps are same. It will check if it's in URL map or not. If it's not, then you will basically download the image, get hash, update URL map and original image map. Like this is the same flow which we had earlier. But if it's in the URL map, then it might be a possibility that it's a duplicate image or it's the updated image on that same URL. Okay, so for that to identify, what you are doing, you are checking the HTTP header essentially, like when this image was last updated, okay, last modified. So you get the last modified from HTTP header and read the last modified from URL map. You are checking in your URL map, you are storing the information of image URL along with when it was last modified. Okay, so you will compare those, and in case the last modified from URL map is less than last modified in the HTTP header, in that case you will do the further processing, as in that you will see that yes, this is more recent image, this is the more updated image for that particular URL itself, for the same image URL. So we have to process this image again. So you will download the image again, get the hash and then do your processing, as in you will store that image and then further do all the checks and place and all the checks which you have to do. So this is all about what we will be discussing today. We will meet again in the next week with a new content, new system design and distributed systems content. So stay tuned. Till then, stay safe. Tata. Bye bye.